Hello and welcome to the first edition of the World Climate News. Today we will be looking at the stability of the Antarctic ice sheet and deadly tornado series in December 2021 in the US. All links are listed in the video description box down below. Utrecht. Global warming heats up the planet and melts the ice of glaciers and polar ice sheets. The melted snow and ice flows into the oceans and causes the sea level to rise. But by how much will the sea level actually rise in this century? In 2009, the climate researcher Stefan Rahmstorf from Potsdam, Germany, and a colleague warned of an impending rise of up to 1,90 m within this century. Sea levels would probably rise by more than 1 meter even with a relatively low greenhouse gas emission scenario, with a warming of 2 degrees Celsius in the 21st century. The Intergovernmental Panel on Climate Change, IPCC, did not support this idea. In its sixth assessment report of 2021, the panel assumed a sea level rise up to 2,100 from 44 to 76 centimeters in an intermediate greenhouse gas emissions scenario. How can future projections differ to this extent? The reason lies within the climate models, which so far have not been able to resolve all the processes involved accurately enough. In April 2021, however, science took a decisive step forward. René van Westen and Henk Dijkstra from the University of Utrecht published the results of a sea level computer simulation in the journal Science Advances. Models with such a high resolution have never been available so far. Until now, ocean currents were only included in climate models in a simplified form. In reality, however, a large number of small-scale water eddies in the range of 10 to 200 kilometers develop along the currents. The two Dutch researchers have now been able to prove that the previously neglected small-scale water eddies are indeed of global significance. They ran the climate models once with and once without the water eddies. Surprisingly, they came to widely diverse results. The global sea level rise is influenced by 4 important factors: the melting of the Greenland and Antarctic ice sheets, the shrinking mountain glaciers in the rest of the world, and the expansion of warming ocean waters. The inclusion of water eddies in the new high-resolution model has now changed all ideas about the future development of the Antarctic ice. Until now, it was assumed that the Southern Ocean around Antarctica would warm up strongly in the future. The warm water would eat itself into the ice shelves, causing the ice shelves to shrink. With the barrier gone, the melting Antarctic ice sheet will flow into the sea faster, leading to rising sea levels. However, the new simulations show something completely different. The ocean around Antarctica is hardly expected to warm up. Some regions are even likely to get colder by the end of the century. According to the new calculations, the ice melt caused on the coast of Antarctica is only a third of what earlier, lower resolution simulations suggested. And because the new model also expects more snow to fall in Antarctica, the Antarctic ice mass is probably going to remain unchanged and overall stable this century. That means that Antarctica will probably make no contribution at all to the global sea level rise up to 2100. This reduces the expected rise in sea level for this century by 25%. While the old model anticipated a sea level rise of about 42 centimeters, it came down to only 33 centimeters and therefore 9 centimeters less. A figure that is far away from dramatic scenarios anticipated by the Potsdam Institute for Climate Impact Research. The study gives reason to hope that the global sea level rise will remain manageable in the next decades through adaptation and coastal protection measures taken. The paper was published in April 2021 in the journal Science Advances. As the study missed the literature cutoff date for the latest IPCC climate assessment, the results could not yet be incorporated into the overview report of the United Nations body. United States. In December 2021, a series of tornadoes caused great damage in the southeastern USA. More than 85 people died. The maximum strength of the storms in Kentucky, Illinois, Arkansas, Tennessee, and Missouri reached a 4 on the 5-part tornado damage scale. It was strange that the tornadoes occurred that late in the year. Typically, the tornado season focuses on spring and early summer, so from March to June. After the catastrophic event, a public discussion developed whether the tornadoes had anything to do with the climate change or not. On December 11, 2021, US President Joe Biden said, quote, "Well, all that I know is that the intensity of the weather across the board has some impact as a consequence of the warming of the planet and the climate change. The specific impact on these specific storms I can't say at this point. I'm going to be asking the Environmental Protection Agency, EPA, and others to take a look at that. But the fact is that we all know everything is more intense when the climate is warming. Everything. And obviously it has some impact here, but I can't give you a quantitative read on that." End of quote. Technically, the president could have saved his breath because there are already plenty of data sets and statements on this subject. For example, the tornado commissioner at the German Weather Service DWD, Andreas Friedrich, told news agency R&D in mid-December 2021 that there is currently no evidence that the series of tornadoes may be related to climate change. At the moment, it is not even possible to say that tornadoes might be occurring more often in the USA than in the past. Let's take a look at the data. Chris Martz has recorded the tornado statistics for the United States according to data from the National Centers for Environmental Information, NCEI, for the last 65 years. The weakest in blue is Category 1, followed by the red Category 2, yellow Category 3, green Category 4, and the strongest Category 5 tornadoes in orange. There is no visible trend. Andreas Friedrich is right. The NCEI is a branch of NOAA, the US Weather Service. On another NOAA server from the National Climatic Data Center, NCDC, a completely different set of statistics can be found. In this version, the number of tornadoes seems to have increased over the past decades. Oddly enough, the tornado statistics look quite different at NOAA a few years ago. At that time, they warned that data before 1995 was incomplete due to observational constraints. Complete tornado data coming from the Doppler radar are only available since 1995. NOAA is falling into its own trap and mixes up data sets with completely different coverage ratios. Why the NOAA does this will remain a mystery. The German Weather Service obviously does not seem to follow along with that. How will tornadoes develop in the future? Here too, the opinions differ widely. Some researchers believe in an increase in tornadoes fueled by warmer temperatures. But it's not that simple. True, tornadoes need warm, moist air near the ground, but there is cold, dry air needed above as well. If it warms up in the future, the tornadoes will be weakened. A similar situation occurs with wind shear. But it's unclear how this will develop as well. According to Matthew Woods of the University of Illinois at Urbana-Champaign, tornadoes might become rarer but more violent. The bottom line is that the future remains uncertain. What is known is that socioeconomically normalized damage from tornadoes has declined over the past 7 decades. Roger Pielke Jr. demonstrated this based on an updated graph of Simmons and colleagues. Therefore, the tornado climate debate ends inconclusively. That's it for today. For any thoughts or recommendations, feel free to use the comments section. Thanks for watching and see you next time.